just pull up the meetup thing to see. Oh, that's probably why. Oh, by the way, we did a free little 1-hour workshop. This is a monthly thing that we're doing. We like demo all the stuff that we've done the past month. Like we call it kind of demo day for us each month to show what we've done here. So keep an eye on those. Where is tonight's? Is it warm in here? All right, so yeah, we'll dive a bit deep into TPUs. Just to manage your expectations, I don't have a whole lot of performance numbers. We barely got this thing stabilized, so, and I don't like to get in that business. Coming from Databricks, where they were very anti-benchmarks, or sorry, they were anti-people besides like Databricks doing benchmarks, right? So, yeah, that was one of the funny things. When I joined the IBM Spark Tech Center to help build that out, we tried to reproduce a lot of the benchmarks that that we had done back at Databricks, and I was kind of loosely involved. And we literally could not reproduce. We had like bare metal, huge IBM servers. We couldn't get what they were showing. Oh wow, 630 people. Yeah, how'd you all fit in here? That's crazy. Yeah, that's why it's so hot, huh? If you guys haven't used Cloudflare, or actually I should ask that differently, who uses Cloudflare? Yeah, Cloudflare is awesome. So I didn't know about these guys. I think there was a Hacker News story where they can like quickly get you up on SSL, so you can turn on SSL, and they, so going through their DNS, and it's a bit of like upfront work, but I have all these vanity URLs now that I swear by. I think of something new, and I pay them $5 more, and I just keep giving them more money per month. But yes, anything you can think of, YouTube, SlideShare, all that stuff, quick starts, like facial cream.PipelineAI. I'll have to add that later tonight. What else do we have? Okay, I spoke at Strata last week, and the night before I was looking at what talk got accepted. I thought I had it covered, and it was the one topic that I had not done any research on. That was the one that Strata accepted. So I spent all night last week building these slides. Yeah, has anyone used TFRecord format, the file format? Yeah, a couple people. And so just kind of digging deep into that and figuring out, there's so many like deprecated APIs now within like TensorFlow. It's like hard to tell what's actually used and not used. So half of my slides were, this is used now, and this was the old name for it, and that kind of thing. So I'm going to spare you those details, but I did post the talk, and it's slideshare.pipeline.ai. You can snag it there. It's in my presentation here tonight, but my presentation is now 240 slides or something. So not going to cover all that. Maybe I'll just jump to the highlights. Yeah, but this TFRecord at a high level is very similar to Parquet, right? Like think of it kind of conceptually. It's a binary format, which is a little scary for people. It's scary for me still. When you're, if you just want to crack it open and see what's what. So yeah, but it's the optimized way to do it. And it's the native TensorFlow format. So just like Spark prefers, Parquet, yeah, TensorFlow prefers. Let's see how long that lasts. All right, so I think we should just jump right into the TPUs. Yeah, actually, before we do that, this is something I was highlighting this morning on the workshop. So there's this new concept that we've been that we're starting to promote. This is like a little bit of our secret sauce, but of course I'm not good about secrets, so these made it into my slides here as early as slide number 25. If I show you if you go to community.pipeline.ai, and you'll see some new tabs over here. If you go to Pipeline DB, so check this out. This is actually based on ModelDB, which is a project that people get really excited about when they see it, and they don't really know quite how to integrate it. And so we've been playing around with this pretty closely the last couple weeks. And so this is a way to like visualize your runs to support. So this is like the entire pipeline, right? So you can instrument the pipeline at like various parts and call back to this, right, like pipeline DB. And the types of things that you want to maintain, so there's this kind of holistic view that like we keep promoting, which is you can hyperparameter tune the whole pipeline, right? Like most people talk about hyperparameter like tuning on just the like training side, because that's all they know, or that's all that they have ever seen. But we actually talk about hyperparameter tuning across the entire pipeline. So this is on the training side, obviously, there's a whole ton of things. There's learning rate, batch size. This is usually where most data scientists end, and it's not their fault. It's that they've never had, right, these other like metrics and right, like attributes that they could track. And so think of the ability to actually make predictions based on, there was, one particular model type, which I actually kind of forgot here, but, and let's say this is linear regression, something like that. You could track the actual EC2 instance and different characteristics about how this was trained. What type of like network was used? Was it 10 gigabit? Was it inside of an Amazon placement group, which is super important because you're kind of guaranteed that everything, that all those workers are as close as possible. You can actually track the like training precision bits, right? So how many bits have we allocated for each float? Typically this is 32-bit. Here we're actually tagging it, saying no, this particular training run was 16. There's also different accelerator types, right? That's the generic term for these GPUs and TPUs. There's new ones coming out by Cerebras and GraphCore and all kinds of people. And so like the ability to actually track these things and then like make predictions later on. But right, there's more than this, right? So there's after training. Oh, and so there's all the characteristics that are the hyperparameters, right? And you can consider EC2 type as a hyperparameter. Like, it doesn't really seem like the classic like definition, but it was something that could have signal in the future. And you could, so certain models might do better on really different hardware. And so this is all sort of this fundamental thing that I picked up at Netflix, which is like you never know how performance is going to be, right? On the training side, on the prediction side, right? Like not until this model actually makes it out into production or is put onto the hardware to be trained, right? Like there's always one more thing that you forgot about. It's typically network. It's typically, right, like placement group or some checkbox that you just didn't know existed or some like new feature by Amazon. On the training like results side here, there's things like the training accuracy, the training AUC, validation accuracy, time to train, right, in seconds. These are things that you want to keep track of. Also, we could add, I talk about this more on the inference side, but we could add, right, like cost per, right, like data row or, right, like example that's being passed in or cost per epoch or cost per, right, like something, right? And so you could just do some simple calculations. So, right, like imagine all this feeding into this model DB, this, what we're calling pipeline DB. And let's just kind of click into one of these here. So there's Scikit-Learn like bindings. You could actually call a Python method at the very bottom of your scikit-learning training job. That'll call back and can tag with all this data. And the cool thing about the Scikit integration is that it will automatically go in, and if I can pull it up here, we'll show you a visualization of your pipeline. So this is pretty basic stuff here. This is like just a simple pipeline, but because it's Scikit native, it knows how to dig in and actually look at the pipeline. Same with Spark. I actually don't have a Spark example here, but so Spark ML has the same concept as Scikit, right? Like in fact, the initial versions of Spark ML were all these weird terms that like nobody used except people in the Berkeley lab. They've since, as of Spark 1.5 or something, now support the same terms as Scikit-Learn. So transformers and like estimators and all that kind of stuff. So yeah, this is pretty slick. And so being able to tie all of this together, the entire pipeline. So there's this sort of middle phase between training and actually pushing it out, right, for the inference, for the predictions, right, which is this like post-training optimization step. My business guy who comes from NVIDIA calls it a hardware-specific optimization, which is right, like the other way to put it. We look at the target environment that you're going to, what type of GPU, if it's a TPU, if it's if you want to use a different runtime, for example, right? Like these are all hyperparameters that will like end up in and like tied together inside of this pipeline DB. So the various optimization, right? These optimizations are like batch norm fusing, right? Like weight quantization. If you had full 32-bit on training, you would then like quantize down to 8-bit. We're starting to see 2-bit and even 1-bit like quantization, which is kind of crazy. And yeah, so you could start to collect too, right? Like how much did this weight quantization actually affect the size of the model, right? So you can dump sort of anything in here that you would then later, right, like want to make predictions with. So this is really the first time that you'll see this whole thing, right, like all coming together. And then now the inference side. So I mentioned the runtime. If you're using TensorFlow, for example, you could choose Python. You could choose the NVIDIA TensorRT. You could choose TensorFlow serving, either CPU, GPU. Most people actually just use Python, right? And they're putting it behind a Flask app. Oh, speaking of which, I like to throw this in. Just last week, I got so fed up with people talking about Flask apps that I registered noflaskapp.com, and it goes to Python. So if you hear people on your data science team talking about Flask apps, just point them to that site. All right, and then, yeah, so you would want to track, so what most people do is just call Python, right? So they're like, there's some like REST endpoint, or there's a Kafka consumer that's like literally like pulling things off of Kafka and then calling Python. It's the absolute slowest way to make these predictions. So I said this over and over, but if you could have like an easy way to try your model out on Python versus TensorFlow serving versus TensorRT, right? This is huge because you don't know how the performance is like going to be, and from our experience, performance has been all over the place depending on the model. So there's no real right answer here. The other thing, yeah, so you can tune some of these other hyperparameters, right? These are hyperparameters that are relative to the actual runtime environment. This is a term that my business guy doesn't like because he doesn't quite understand runtime. He doesn't think investors understand runtime. I'm cool with that. I don't care. I'm going to call it runtime. Yeah, they can call it inference, or they can call it, yeah, he wants to call it server, which I'm not going to let him do. So it's not pipeline server. That would be like 1960 or something. All right. Inference, and so you could do the request batch size, batch window, if it's 10 milliseconds, something like that. These are all hyperparameters that the data scientist can now tune and like start to experiment with. And so with this comes a need for a fast experimentation framework, and obviously that's what like pipeline is. But part of that is the ability to actually track all of this stuff and then mine the data later. So this is the real secret sauce behind pipeline, which I'm revealing to everybody. So, and then on the results side, so there's this kind of hyperparameters that we have choices of, and then there's the results. There's other ways to get this data, of course, but this is kind of a nice central place to like put everything and see it side by side and have it come up on nice UI. For the like inference, right, like every 15 minutes or something, you would call back to the model DB, right? Yes, this model is actually calling back and saying, right now I'm at 5 milliseconds for my 99th percentile latency. And so this is super important because you can kind of then start to see if there's degradation. Right? Like pipeline up till now has been focused on more the real-time metrics. So if you go to community, put in a fancy little digit here. Yes, thanks to Francesco for helping me figure out the JSON axis was 90 degrees off, right? Like remember that night when I was like, yeah, I can't figure out. I was doing, it's the MNIST, yeah, the JavaScript MNIST thing. And he's like, oh yeah, I switched two numbers, X and Y, and it worked, yeah. So when you do that, if you click it a bunch of times, you'll actually see traffic. And so this is what Pipeline has been focused on, right, like traditionally, is this use case that right, like magic moment when the model goes out, and also the ability to split traffic. So right now it's at 50-50. Yeah, not unless someone flipped it on me. But we could also put B into shadow mode, and that would automatically, I can't figure out the UI well enough to have it flip over. It kept adjusting the other one every time. I get into this weird loop. Yeah, I don't think like these JavaScript folks do. So B is shadowing. A is taking all the traffic. So one thing I added here, because this was confusing, is I'm actually telling you which model variant is serving up this prediction. And so what's interesting is we should see now, make sure, so B should still be getting traffic. Yeah, there we go. A is getting traffic, B is getting traffic, but only A is bringing the response back. And so we can actually log and right, like show these side by side in these dashboards, but then also part of this larger like model, right, this pipeline DB. Okay? Yeah, we added this recently too, so you can quickly grab it. We saw one of our competitors doing this and just added it real quick. So, because we liked it so much. What else? Yeah, here's another little nifty tool here. So been working closely, there's a buddy of mine in Chicago who coded all winter. I saw him, actually I didn't see him at the NIPS conference in LA because both of us were holed up in our hotel rooms working on other things. We came together about January, February, and this is the work here. So there's a way to actually package up your like models and all those hyperparameters, right? And so here we actually trained MNIST with a convolutional network and then the kind of boring softmax network, or right, like softmax technique. And we could actually compare them side by side and look at their accuracy. So as we would expect, MNIST with a convolution, which took way longer, by the way, than the softmax. Got 98, close to 99%, similar batch size, same epochs, and right. But this actually doesn't have it in there. It took about, I think, 10 or 20 times as long. I just forgot about it after a while. Came back and it was done. So you could also view these in, TensorBoard, right? Like originally he was trying to replace TensorBoard, and I, being in Chicago, which is the market I came from, you would think this is something possible, but it's completely not when you're dealing with Google. They've been refactoring this thing nonstop. And the lead developer on this actually shifted over to a different group within Google because people always move around. So they had this whole plugin architecture that he then tried to plug into so that he could have this same kind of functionality, right? Because there's a database behind this. There's more than just right, like TensorBoard event logs. So there's like quite a bit of like complexity in not just the packaging, but also really indexing these results, right? Because TensorBoard does not do any indexing, at least the current version or the last version. I don't know about the current version, but and so if you do have a lot of event files, you're pointing to directories and parent directories, and each time you want to refresh, it has to scroll through and right, like recalculate all these things. So, but yeah, so back to the TensorBoard plugin architecture, it's like completely not pluggable. They try to be, but I'll actually show you guys some of the like TPU specific plugins, and you'll see what I'm talking about. How even Google, can't create a good UI out of TensorBoard as a plugin. Okay. This thing also supports GPUs, by the way. So you could have different runs, and it'll actually tell you, yeah, there's a nice command line and everything that we're rolling into our pipeline command line. Okay, so that was a slight diversion. All right, let me go through, get to the TPU stuff. I've kind of like mixed these slides into my normal presentation, so I'm gonna have to skip a little bit, but Yeah, there's the TPU. Now these things run, at peak, they run in these pods. And a pod is 256. So I didn't get 256, which is probably good because times $6 an hour times 96 hours, I'd be pretty broke right now. But yeah, so I'll show you guys. This is all the slides I came up with for Strata and TFRecord and all that stuff. And you just got to learn to love protobuf. Can't really fight it. If you are interested more on the like TF dataset side, so this is TensorFlow's Dataset API. This is where you'll start seeing things that are similar to Spark's API, like maps and filters and like iterators and all that stuff. So this is the like TF dataset dude. Yeah, Derek Murray, he works for Google. Yeah, he's more than TF dataset dude. I've been trying to get him to come speak, so I hope if I continue to kind of like deride or like put him down or like call him names that he'll finally show up and like punch me in the face. But at least he'll do it here and we can ask him some questions. He's very approachable. He's on Stack Overflow and all that. Let's see. Okay. So when you're dealing with these TPUs, one thing that was pretty obvious from the beginning, even before we had access to the hardware, was that there's a separate API for these things. So right, like you have to know the, right, like TensorFlow, right, like the new Estimator API. B, you kind of have to know a little bit about what's going on beneath the covers to like really understand cross-shard optimizer, right? So what we're doing here is we have our own like TPU estimator, our own TPU config that has, you know, these concepts of shards. And then for the optimizer, we actually wrap the normal optimizer that we're going to use with the cross-shard optimizer. And this is actually handling the distribution, right, like between, yeah, so these TPUs are not meant to be used one at a time, right? They're meant to be used in these big pods. So you just kind of have to get like used to this stuff. So I'm going to show a couple. Yeah, so this is actually from TensorBoard, and I'll show you guys live the TensorBoard here in a sec. But what's really interesting, yes, I want to highlight this. This is kind of a segue from the dataset stuff before in the flow of my slides. But so this is like the first time that we're seeing a dashboard or right, like graphs that actually back up further in the process, right, like further in your pipeline. So there's this prefetch thing, which is all over the TensorFlow documentation. And right, like this is all about, right, like prefetching data. You could see what percentage of your data that was sent to the accelerator was actually prefetched. So this is big. You know, this is just one view of this overall concept. So just kind of bear with me here. But there's human readable things too that we'll see here in a sec, where they're actually telling you that you have an opportunity to actually prefetch and to add more threads, right? Like beneath the scene, it's actually spinning up multiple C++ threads and like doing its thing. They also push quite a bit GCS, the Google Cloud Storage. That's like all over. And of course with TPUs, you pretty much have to use GCS because you like can't hit these TPUs on like S3, and it would be completely ridiculous to, from the TPU, be like pulling data from S3. So this is where they get us, right? Yeah, this is where they get us hooked. Yeah, so here we see was this 8 threads, and they'll actually say, okay, there's one prefetch thread. We think you could actually add more threads. This particular VM is being underutilized. So these actually show up in the dashboard, which is huge. Probably some of you have already seen the like TPU compatibility. This cracks me up. This is the best form of marketing ever, right? Like give a tool that is really tied to this particular neural network framework, this like numerical processing framework. And oh, by the way, you could be doing things a whole lot faster. Or right, like, wouldn't you be interested in trying it? Because we could actually optimize 92% of your graph. And yeah, this has been getting more and more because yeah, this actually popped up, I think, in 2 or 3 tensor boards ago. And yeah, I was always curious. I would go, but it'd be 50%, so I didn't really care. And then, yeah, now it's like 97, 98%. So more and more of these TensorFlow operators are starting to be built for like TPUs. And of course, nobody knows this hardware except Google, so this is all coming from them. And so this is where you start to realize why they don't spend too much time on the GPU stuff and why they really rely on the community and like NVIDIA, like engineers and that kind of stuff to fill in these like GPU gaps. Yeah, so they obviously use GPUs as well, but they're spending all of their like pretty much all of their resources making these TPUs the fastest thing out there. All right, so this is one of the screens that actually is a plugin for TensorBoard. There's this new profile tab that shows up. You have to actually install this Cloud TPU Profiler thingy, and that gives you access to this capture TPU profile. And so this process, you actually give it a TPU name and give it a directory. It's the same directory that TensorBoard will start up and then listen to, right? And this thing is just a background process that's running. It's constantly pulling the TPU. You actually run this, so like backing up a sec, so these TPUs are not actually part of the VM. So one big difference between Google and the Amazon GPUs, and it was kind of interesting, was that all of the Google GPUs are separate, right, like network attached. So they're not actually on the physical boards. And so that's something to actually keep in mind. That would actually be one of the metadata things that you would pass to the pipeline DB, is that this is network attached GPUs. This is significant. You want to know approximately the speed between that, right? This is huge. So in like contrast with like Amazon, it's kind of a fixed profile. You like pick an instance, you have one set of CPUs, one number for the RAM, and all the right, like various things. If you guys don't know, there's this ec2instances.info. This was built by one of my friends at Amazon that has since left. But the first day that my buddy started with Pipeline, the engineer guy, he said, "Oh, by the way, I think we need to get one of these new X1 E32X larges." And I was like, "Oh, okay, yeah, let me go see what that is per year." And it's like $150,000 a year or something crazy. 26, yeah, almost $27 an hour. So that's, what is that, four times? Yeah, like 3.5 times the like TPUs. So we're not going to do that. That's not where we're going to spend our precious money. Plus, these don't have GPUs. But yeah, so check out this site. This is kind of cool. You can look at, and there's a REST API too, which is really cool. So you can, like this is how we actually power some of the like cost per prediction things, because we know what type of instance is actually these like predictions and these training jobs are running on. So we could just do the simple math to figure out. Yeah, it ends up not being that simple, but okay. So this is our current dev server. So just ignore that one. But this is a TPU just a regular CPU machine. Now we can add GPUs to this, but what we really want to do is add TPUs, and so that's exactly what we've done. So we actually start up the VM, which is just CPU. So that comes up. That's actually like a pretty boring profile. I think it's 4 CPUs. We didn't need anything big on this one. 15 gigs of RAM. It's actually underutilized because all of our work is being done on the TPU itself. All right, so this is kind of boring, but that's actually what I'm shelled into. And so how that ties back here is I'm going to pip install and run capture TPU on the CPU machine, on the VM. And we're pointing it to the TPU, and it's using this thing called TPU Cluster Resolver beneath the covers. And it's really just calling the like GCloud API, or like REST API, to figure out which zone you're in. And that's one limitation that we found, is that these TPUs have to be in the same zone as your CPU machine, which is probably a good thing, because these are all network attached like devices, the accelerators. But yeah, that's actually in there. It like won't let you actually attach cross zone. Something to keep in mind. And then TensorBoard is physically running on the same. So all of these commands run on just the main CPU VM, and then we've attached the TPU separate and given it a name. So let's go over there. There's this new thing that pulls up here. we see so here's the actual TPU, and it's version 2. Each of these are 8 cores, and what's interesting is when you actually create this mofo here, you have to select the TensorFlow version. And at one point, this said 1.5 and 1.6. I don't quite know what happened, but now it's just saying 1.6. And actually, one of my questions for the guy that was working on it this weekend was if he tried 1.7, and he hadn't yet, so I haven't either. But select the network, all this stuff, give it that, and as long as it's running in the same zone, then we can get to it. Okay. And so the cool thing here is there's actually human readable like suggestions. It's telling you the one number that they show over and over is this TPU utilization, which makes sense. Flops utilization is how it's termed, which is a little confusing for me because I'm more used to thinking of GPU occupancy and like GPU utilization, and I don't know why they have to put flops in there, but they can actually show you also top 10 of the operations, right? These operators, which ones are taking a long time. There's also an XLA component here, which I don't know is on this one, but I could show you guys the live dashboard where they could show you which operators have actually been compiled and fused together. Yeah, so that's really cool that the TPU stuff participates in XLA. We didn't really expect it not to, but, and these things in red, you can't see it, but your program is not bounded by input. It's on average, and it tells you. So this is what you want to keep an eye on, is how early in the pipeline are you bottlenecked? And the problem with these faster accelerators is that we typically can't get data to them fast enough, right? So they're really spending quite a bit of time trying to highlight this. And I was speaking with the TPU product manager the other day, and I was asking him about TensorFlow serving on TPU, and he said that they're not really focused on that right now. If you go to TensorFlow serving and actually search the repo for that acronym TPU, there's nothing that shows up. I think there was a typo that was, something similar, but it had nothing to do with TPUs. Or I think TPU is in that sequence of characters was inside of a word. The GitHub search is pretty shitty. But so this is like another view, and you can drill in and see per operation which ones. And what's cool too is that they'll actually highlight and say you're padding a bit here. Here was an exact fit, based on batch size and the way, those dimensions of these matrices that you're expecting, versus how the data is actually coming in. And so again, these are more ways for you to not blame the accelerator, but to blame the rest of the pipeline. That's how I like to think about it, is a blame game, right? You have to blame someone for the performance being shitty, and they're trying to make sure it's not that. So overall TPU flops utilization is 41%, which is green. So that's pretty decent. It's not sub 10. Here's more of the input analysis. So this is kind of cool. It's a pie chart showing, I can't really see what the legend is there. On the live one I could zoom in, but it'll show you a nice chart and say most of the time is being spent in the accelerator. That's good. And yeah, start to highlight. And there's more human readable stuff here also. All right. So let me try to get to the live demo here. This is going to be partially command line and partially. All right. So let's see what's going on. So I ran a magic script. I can show it to you in a sec, but we're building up the TPU config over there, which is a little different than the regular run config in TensorFlow land. We've got a Google storage bucket for the output. There's input somewhere is also up here. We've got number of the replicas. So I didn't have to specify any of that. If you give it a list of TPUs, it'll figure all that out. It will assign one master. Not 100% sure the failover stuff. From what I've read, and this is something we didn't get a chance to actually simulate, but like you could actually go in and stop one of the TPUs and the workload goes around it. So that's actually really nice because like just normal distributed TensorFlow, if you're trying to do it yourself, is a total pain in the ass. There's no zookeeper, right, like out of the box anyway. So you have to do all that stuff yourself. And right, like now it makes sense to me why Google is so fine with like the open source and the GPU stuff and the CPU, right, like distributed TensorFlow story being so shitty. It's because this is what they've been focusing on, right, like making this super easy to I don't actually know if you could scale up. I don't think you can. This is one big like limitation about TensorFlow is when you specify the run config or the TPU config, that's fixed. You have to give it. Actually, do you know what? That might not be true because the entry point now is the pod name for all of these TPUs. So actually, yeah, they might be able to actually scale up. But that's been a huge limitation about like GPU and on the training side is that you can't add more nodes. I mean, I don't really know why you would. It's a fixed training job. You know how much money you're willing to spend on the job and that kind of thing. But yeah, just know it, like distributed TensorFlow, scaling up, scaling down has always been a little shaky, and these TPUs make it nice and easy. Also, the TPU Profiler kicks in because that was a background process that is just sitting out there waiting for the TPU to be active. Let's see. Traces here, I picked it up, starting okay, it's tracing, giving us a lot of, let's take a look at this part of it here. All right, so it's initializing TPU system, boom, boom, NQ, next 100, EQ, it's checkpointing. Now, let me show you the code. Oops. Sorry for the color. So there were a couple bugs that were keeping me and my guy up this past weekend, which, so one of them, you can't use Python 3, and this is an obvious thing because we know Google primarily uses Python 2. Python 3 is always kind of an afterthought. They rely on the community for that. So it's the classic string versus bytes. Yeah, you guys know this problem if you've done that like migration. And so what happens is when the TPU resolver is trying to figure out, it's using the Google API, like Google Cloud API, it's pulling back the name of your project and it's in bytes. And so they're trying to construct a URL with the little B and the quote and a single quote, and that doesn't work. When you switch to Python 3, there's other problem, or Python 2, there's another bug where they can't seem to like resolve just the name of the TPU. So this should be -- TPU name, and then here we're actually explicitly saying here's the master, and you can either specify one or the other. And TPU name didn't work. You can actually pass a like list of names, and that ends up becoming the TPU config, and that's the fixed cluster at the beginning of this training job. This is my favorite. You could say use TPU is true. It's one of those things like, really? You have to have like true, false if you start to add other accelerators here, but they're betting the bank on TPU. All right, so cooling. Oh. Okay, there's that pesky cluster resolver. You can see us trying a bunch of different stuff here. It's still in the code, but yeah, there's TPU run config, but then I believe this config gets wrapped in a TF config or a TPU config later on here. So there's the TPU estimator, use TPU. see. Where's the TPU config? Oh, I think that's probably hidden behind, yeah, okay. Anyway, this is some of the nastiness here. This is the Estimator API. You have to know this, otherwise this code will make very little sense to you. So the Estimator API, just real quick, is a way to have callbacks so that you can distribute your, what would normally be a top-down, or like Python script or like Python, like training job. There's callbacks to get the data, to get the input data, to get the evaluation data, and that then lets a higher order sort of coordinator then, right, like distribute these, and then each worker can then pull and follow the same code path, but on a different chunk of input. Okay. I think that's probably it there. Let me start TensorBoard. TensorBoard log equals, is it knowledger? So one cool thing is from the actual SSH, so that, there's this fancy SSH that you can use with GCloud. And you could actually set up the port forward all in one line. So I have my local port 6006 mapped to the VM, so I could do this. All right, so here's that profile tab I was talking about. Let me jump over to the graphs real quick. So this is why my buddy created, right, that extra thing. This is, just to load up the graph, it has to linearly go through all of the event files and render it. Where's that noise coming from? All right. So it's over here somewhere. I was having this problem earlier today. Okay. Oh yeah, there it is. So this is ResNet. And it's really long in certain places. But let's see, let me zoom in here. Let's put down my beer, which I'm not happy about. Scroll. Scroll, 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 scroll. Scroll. And I lost it. Okay, let's hop over to the good stuff. Actually, yeah, my buddy who ran this job all night from yesterday till today was all excited about the projector tab, and I was like, that's always been there. Why? This is a way to visualize the data sets, and it's it's that cool PCA T-SNE. You can spin it around. Has anyone used this? The projector tab? Francesco, do you use it? Okay, but more importantly is this profile tab, at least for this talk, not overall necessarily. So here's some of those screens we were showing before. Let me get to, so we can actually click and see the top. So these are the top operators where time was being spent. You see the XLA is at the top. I don't know where that's coming from. Problem solved, I think, I hope. Okay, and then a little bit more information about the batch size. And then this is kind of cool. It's a reference to what they're calling the Input Pipeline API. It's basically the Dataset API. One thing in preparing for recent talks, I do want to point out there's been some additions to the performance tab off of TensorFlow.org. And input pipeline performance guide. There's another one here. There's like a nice big post about quantizing some of the optimization, that second phase that I was talking about before. But really, yeah, if you want to look at tips on how to improve your actual pipeline, you would want to go here. And between this and that like Derek Murray stuff, there's like a lot of good info here. But the summary is use Google Cloud Storage and use TPUs. Right. Let's see, I think that's it over here. Oh, I wanted to show one more thing on the TensorBoard. Yeah, this is that input analyzer, and this is where it's going to tell you in human terms what you're doing wrong. So this piece of the pie, 78 or 79, almost 80%, is enqueuing to be transferred. That's not a surprise. Reading data from files on demand, pre-fetching, things like this. So these are things that you want to keep an eye on. My assumption here, this is only the second or third time I've been looking at this, is that green is good. Increase, let's see, what does this say? It's telling you sort of obvious things, and then you have to kind of translate it into what you have to do at the API level. Enqueuing data, you may want to combine small input chunks into fewer. It's like when you go to a fortune teller or you read your horoscope and you're like, yeah, that totally applies to me, right? Because of course, you always want to have like larger chunks. You may increase num parallel calls, so that's kind of interesting. Pre-process the data offline. Prefetch size, so these aren't specific. These links are actually just to the generic docs. I'm curious how much these will actually start to be dead links after a while and go to a 404 somewhere. But yeah, it always makes me nervous when I see people embedding like documentation links into code. Let's see, reading data. You should read data in advance. So that's capital letters. That's serious business there. Consider Dataset API. And the last one, so if you've seen any of my workshop talks, we spend quite a bit of time looking at the GPU and how it's being utilized. Let me zoom out here. This is the other thing with TensorBoard, is it's very sensitive to if you're zoomed in or zoomed out. So in the workshop, and so before this profile tab hit the scene, and I'm not 100% sure if this profile tab, so the process that you run on that slide earlier is capture TPU, and the pip install is TPU. So this makes me a little skeptical that it's actually going to work on CPUs. But what's kind of interesting, and so this is why I was highlighting that this is actually installed on the CPU machine, right? That these TPUs are being attached to. And so this is capable of generating CPU side things, right? Like the data, like pipeline and the ETL and all this kind of stuff. So it might work on a CPU without a TPU, and it'll just not show any TPU metrics. I don't know for sure. That was one of my questions we didn't get to this weekend, but let's see. Yeah, and so this is actually showing where the XLA is kicking in. So these are the TensorFlow operators. There's a lot of stuff going on here because of ResNet, and which ones were actually fused together through XLA. Shows you TPU core 0, core 1. Very similar to the workshop when we look at the GPU. The GPU profiling shows at the stream level, right, the GPU streams, which is a CUDA concept. Oh, wow, look at all this. So actually didn't scroll down here. Where it's showing, yeah, this is where the screenshot came from for the input, the pipeline threads. So these should be tied to the Dataset API or something similar. And then prefetching, how much time is being spent prefetching. And there's the screen here for the percent utilization. So, okay, did that whet your appetite for TPU for now? You? Yeah? Any questions? What were you hoping, or what haven't we covered? Yeah, for the benchmarks, for the side-by-side comparison, yeah. Yeah, we're getting there. Yeah, anyone else? Questions? Yeah, please tell us, because we're always, I told my buddy, I'll bring all the feedback. There's obviously going to be a lot of questions, I think, around performance and how does it compare to GPUs and cost and all that. Yeah.
Training and then optimization.
Yeah.
I was wondering if there's any heuristics you guys found.
Yeah, it's pretty. Let me find that slide. It's pretty early in our data collection on that front. For the most part, what we're feeding back to people what is taking the least amount of time, right? Because there's going to be trade-offs. The problem is, and we always kind of avoid the cost thing because we like doing this stuff, and if we talk about cost, they're going to stop it. So fortunately, these are big companies, and this money tends to flow pretty readily, which we like. Where is that slide? Number 25. Yeah. On the optimization side specifically, right? So batch norm, the quantization stuff is pretty nice. One question about that, people always want to know, and so this is why, so I didn't mention on the inference side, there's longer term metrics, right? So up till now, we've been really focused on how is this model doing right when it's deployed? And, is it totally crapping out? Is it not on a systems standpoint specifically, but also predictions side by side, right? Is it predicting in shadow mode on the same inputs, how far off from the main model, the main control model that we're experimenting, that we're trying to find a better version. But there's longer term metrics. So there's things, so 24 hours later, right? You can't calculate something like AUC without labeled data. And so after 24 hours, 48 hours, right, that's when you start getting these labels. You're running Spark jobs, you're collecting data, you're feeding it back into the pipeline DB. And yeah, so I'm kind of talking about the whole thing here. So TensorRT, I'm doing a talk next week. Not a lot of people, so TensorRT is an alternate runtime provided by the NVIDIA folks. And there's there's a step between your trained model and that falls into the optimization, which is essentially converting into TensorRT's bytecode or whatever you want to call it. They actually were building their own. It was called Unified File Format, UFF. This was an NVIDIA thing. So as we all kind of know about NVIDIA, they're a hardware company, and whenever they try to go towards software, there's so much momentum elsewhere, and so I think they're actually sunsetting this weird UFF format and going towards Onyx. Yeah, which is kind of interesting. But for right now, they can work natively with TensorFlow, with trained TensorFlow models. They'll fuse things together. They'll do, the problem is, so this is what I was getting at is, with TensorRT, we're expecting a whole ton of performance gains because they're doing CUDA tricks and all these weird things beneath the covers, especially on the Jetson, right, the small GPU that's running on these autonomous things. So the problem is we can't really get it to work properly. So the things that's really where we've been focused is these smaller devices, right? And there's also one more. There's TF Lite or TF Compile was kind of concept where you're creating a smaller footprint, a smaller runtime footprint, and just pulling in what you need. So the short answer is we don't have enough data. The area where we thought we would see the most gains, we can't get it to work. The areas where we are able to get it to work, which is actually also a smaller subset of all of the potential models, right? These are very image, so ResNet is supported, right, MNIST, so TensorRT can actually, right, convert those. But there's times when TensorRT just craps out and says, we can't convert this particular operation or this particular neural network. But the fusing stuff works pretty well. Francesco could probably talk more when you're up here about some of these optimizations. And yeah, have you done a lot of quantization and things like that? No? Okay. Oh, it was the other Italian stallion. Yeah, Fabrizio. Yeah, he's a big quantization guy. But the big question is, how's the accuracy, right? And you really can't measure that until you have labeled data, until you've actually, figured out, are people, right, like converting, are they clicking, are they buying, are they doing whatever is your objective function. Yeah.
Just follow up. By adding additional, let's say you add additional network configuration or whatever, does that mean you spin up a different model and have that training with that?
Yeah, exactly. Yeah, exactly. So I think the high-level question is, these are like distinct runs. Yeah. And so these are, not the cheapest ways to experiment, but it's really the only way. Like, you can do only so much on the whiteboard, and but not until the actual data set's running through this and you're on the actual hardware. And so our goal, what we're trying to get to, is a point where we can actually make recommendations and say, for most linear regression with these kind of characteristics, with this data set size, and this is what we recommend, right? So our worst case scenario is, yes, obviously, like, we're not making good predictions, but it's always a question of, what are you trying to optimize for? Is it just getting the jobs done quickly? Then our recommendation is going to be just horizontally, scale it out. But yeah, there's a point too when that doesn't work.
You guys also tried out like population-based kind of training?
What would be some of the hyperparameters there?
I'm not sure, but I think we came out with a paper like a few months back about tweaking learning rates, and then whichever has the best performance. Yeah. So like doing like an adaptive, so they're all like communicating, like kind of thing? Basically, you have multiple training in parallel, and then
totally
the best model you swap.
And then continue the rest of it. So gotcha. There was a paper at NIPS back in December that was about, I think it was ICML in Sydney back in October from Google Brain and Jeff Dean and all those guys about, right, like adaptive like device placement. And that's the ability to, as the training job is running, and these are really long running jobs, they'll shift traffic over to the GPUs, or certain portions to GPU, certain portions to TPU. Right now, you kind of have to do that by hand, but this paper was about reinforcement learning and being able to dynamically adapt throughout. But yeah, that's really interesting. Yeah, so there's a paper on it's called population based. Okay, and so I guess what you'd be tracking there is how much time, and like, do they actually shift back and forth, or is it just there's?
You have multiple training in parallel, and the best model that's performing the best, you take those weights and then swap it with all the ones.
Gotcha. Okay. Yeah. Any other questions? Yeah. So when we first started Pipeline, we're like, oh, we're going to be CI/CD this and CI/CD that, and really, so there's the incremental training. Oh, which I didn't mention, by the way. We finally got TensorFlow working with Kafka in a pretty smooth. 1.7 has, for the Dataset API specifically, there's a plugin for Kafka topics and supports Kafka 10 and above. I'm using it with the latest Confluent. And the goal here, and I work on this every other day, and I haven't. So when you fix the prediction, for example, like you would either do it here or you would do it offline. If these are all 10%, 10%, if it's unconfident, it would end up in a Slack channel. But here we're kind of demoing it explicitly, saying, oh, this is not the right one. Here's the right label. Fix it. And then this ends up on a Kafka topic and then like the next run. So is your question more about the like dynamic or the sort of incremental training, or is it more about just getting new models out kind of thing? Or both? Yeah, because I guess they're related. Yeah, one thing we're very against is modifying models like once they've been deployed. Again, this is a bit of stubbornness from my Netflix days where when at one point, like we were modifying configs even, and just our like normal services, just like plain old microservices, for example, streaming services. And whenever you make changes to live running stuff, there's bad things that'll happen, both in the short term, if there's a bug and they can't merge, properly, and then also just in terms of, like knowing, yes, like which servers actually got the updates and which ones didn't, and it just creates kind of a heterogeneous type thing that you don't want to get yourself into. So the more kind of declarative or more predictable, like deterministic way is have like distinct updates, right? So yes, even Google doesn't like really do too much of the incremental stuff. They're more discrete. So every update is a push. One thing we talk quite a bit to customers about is TensorFlow serving, which we rely on heavily because we like a lot of the like optimizations in there. One feature that we don't utilize is running multiple models or versions of models or just any model. So we only like deploy one model to one TensorFlow serving process, and there's one process per Docker container. So each Docker image is burned with one model, and that's it. And then any load balancing or any like A/B testing is done at a higher level, right? And not done inside of one single process. The problem again is when you start running multiple variants or multiple models, these are like heterogeneous workloads. They're difficult. Think of this new trend now. Instead of having one huge Spark cluster, and people submitting jobs to it, and you're trying to track down logs, and you have yarn, and you can't figure out like why your job's not running. It's someone left a long-running job. So this new trend, especially with these 4 terabyte RAM machines, is one Spark job or one cluster per Spark job, right? And so each job like pulls together all the containers that it needs, and yes. Right, like Netflix actually does it at like the AMI level, the actual EC2 level. They'll spin up a whole cluster of EC2 instances, and now with the secondly billing and minutely billing and stuff, this is not as wasteful as it was a couple of years ago. But yeah, I mean, I can vouch for the like debuggability totally outweighs, and the like predictability of the job. Like this job is going to run, and it's not going to be throttled behind somebody or 5 other people's jobs. Yeah, so that's kind of nice. We're not using the ability for it, right. It's been problematic for us, especially with some of these hyperparameters on the request batch size and the request batch window and things. When we're trying to tune one particular model, right, like we don't want to have to deal with, right, like resource contention at, that low level. Yeah, I mean, do you have other thoughts on this? Or just kind of exploring it? Yeah, it's one of those things. I've been kind of spoiled because of Netflix, and their like Amazon bill is completely dwarfed by the right, like movie contracts and all that stuff, right? These things are in the billions, and the Amazon bill is only in the millions, so it's easier just to spin up more instances. Any questions from the back row back there? Front row. Oh my God. Yeah, the other back row.
I'm just curious, why did you try to make Kafka work?
Yeah.
Just use Google Kafka.
Yeah. Yeah, you could. I mean, we would have to be. I mean, do we have to be in Google? I guess we could subscribe. If I'm running in Amazon, can I, like, would I ever use their pub sub? Yeah, I always get scared by people like you that are like, use every cloud service possible. It's a completely different way than I think. It's, I get scared of that lock-in, right? But this is why I'm not married, and this is why. So there's deeper issues here than just, vendor lock-in. It's female lock-in, partner lock-in. More on my personal life than you guys want to know, but yes. John, do you have any questions? Yeah, Christina. Ex-girlfriend Christina from Chicago, here in town visiting. Francesco, are you ready?
Yeah.
Is the higher level question, like, why would we use Kafka cluster? Or like, why would we use our own, or like manage our own topics and, you know, PubSub? Yeah. Yeah. Right. And we went through this at Databricks, actually, where we were back and forth because Databricks is so Amazon like heavy. Since they now support Azure and things like that, but we were going back and forth. So we want to manage our own Kafka, do we not? The cost obviously is one thing. And for a small company, it was like, well, the cost of hiring an ops team for this is not really, you know, that's a bit prohibitive. So at the time anyway, when I left, they were using Kinesis and very happy with it. It was just, anytime you had a developer that started pushing more data out there than was necessary, now your Kinesis bill at the end of the month is, you know, 10x what it was. And so, but that's not to say that Kafka would have required a larger cluster as well. You know, you would have had to scale that up. Yeah, I like Kinesis. In fact, I actually contributed the Spark streaming Kinesis thing a long time ago. Yeah, one funny story about that, by the way. I'm like buying time. Are you okay? Okay.
I'll be fast.
Kinesis. Oh, I got a call after I contributed it. I got a call from the Amazon Kinesis folks, and they were like, "Yeah, we would love to talk to you." Blah, blah, blah. They're like, "Okay, so you've built this, and it's very stable, and there's a lot of tests. There's one thing about the code that we don't like." And yeah, I was like, "What?" Like, I spent a lot of time working with their engineers. Like, you know, they're like, "There's no callback to our server, or there's no way for them to know like who's using like this adapter." And so they actually wanted me to put in like a phone home back to some endpoint so that they could track it. And there was no way that, you know, Databricks, the Spark community, you know, whatever, which is basically Databricks at the time, right, like would have allowed something like that, right? Like a vendor specific